Welcome to the channel. So we have discussed about this part, like how the model tries to determine which is positive classes and negative classes by seeing the normal to the plane, like the direction of the normal to the plane. So let's see some of the examples by checking some of the cases. So in the first case, let's see. Supposedly, we have taken one positive classes. So positive class. So if we take positive classes, the predicted would be plus one. That we have taken for positive classes would be plus one, and negative would be minus one. So yes, we have taken the positive class. The real output is the true classes. That I mean. So it will be plus one, and if that particular thing that xi. Supposedly, I'm taking this particular point. This particular point. So this is a positive point. So why why I will be plus one, then how the model will predict, as it is the same direction of the normal to the plane. So it is the same direction. So as it is same direction, so this particular value, the normal multiplication of this particular distance, the data point distance, so it will be positive because it is in same direction. So as it is positive, the model also predict the positive value. So if the classifier actually takes the particular parameter, the yi and the distance, so if you try to calculate, so it also gives you the positive values because this one, so this part, this yy is plus one, and this are the direction of the data point and direction normal is the same. So it is a positive value. So positive into positive would be positive. So as this value is giving me positive, so I can say the model is performing well, or it classified the classes perfectly. Okay, let's take the second scenario where actually we have taken one negative classes. Suppose we have taken one negative classes. So suppose it is a negative class, right? So yes, so for negative class, what would be the output? Yi, it would be minus one, that I have already told you. That would be the minus one I for negative class. And what would be the classifier says, like as the direction of the data point that I have taken, the negative data point, it is the opposite of the normal. So the distance would be negative, right? So the distance, how we are calculating distance, the multiplication of w transpose into the data point, it will be xj, as I have taken the example of xj. So it will be xj. So the distance would be negative as is the opposite direction of w. So what would be this particular value? So yi into wtxi. So this particular value will be negative as the true class actually negative. So it will be minus 1 into what the model actually predicts it, as the direction of the w is opposite. So it is also predict it is a negative. So negative into negative would be positive. So as this particular parameter yi into w transpose index 1 suggests the positive value, so the value is positive, so we can say the model classifies perfectly. So here what we try to conclude, if this particular parameter value gives us positive value, so our model performs pretty well. Pretty well in the sense I'm saying, the it actually classifies positive and negative classes pretty well. But in case this particular values becomes negative, that I can say in case. But here, as we have seen in two cases, so both cases, both positive and negative classes has been predicted perfectly, as this particular parameter gives me the positive value. So the logistic regression correctly classifies the point. So let's see some scenario where this particular value actually uh, shows negative value. Let's see what is the actual true value and see the model actually predict the case perfectly or not. So in the case 3 that I have drawn one picture here. So this is the plane that basically segmenting uh, two classes, positive and negative classes, and we can see one of the negative classes is in the positive side. Positive side in the sense I'm saying, the model what will understand, the same direction of the w, the same direction of the transpose or w value will be, this all classes will be positive. Model will just predict like that, right? And as This data point is the opposite direction of the w. So w is nothing but the normal to the plane, right? So opposite direction of the normal to the plane, so it would be classified as all negative. So model will whatever value down like below of the plane, the model will just predict the negative value. So all the values will be negative predicted by the model. So let's see one point why it actually, let's see. So if my point is positive value, so if my point is positive, suppose this is my positive value, I have taken this positive value, and it is the true class of this particular data point is positive, right? So y1 will be positive, but what my model will predict, as it is the opposite direction of the, as it is the opposite direction of the normal, where normal is in the upward direction. So as it is the opposite direction of the normal, so the model will just predict the negative value. So the distance would be negative. So this positive, and our model classifies as negative. So this positive and negative will give you the negative value, right? So in this case actually we got negative value. So as it is giving me negative value, it is actually showing us that it is misclassified, because the true value of the data point is what, positive, as you have taken the true value data point is positive. But as this value, as our model actually predicting negative value, so this parameter whole y1 into wt into x1, it becomes negative. So we can say our logistic regression actually segregating positive classes to negative classes, so it is misclassified. So let's see one more example with that. So let's see, uh, so as this normal to the plane will be the same direction of the data point, so data point is here is negative. So as it is the same direction of the normal, so model will just predict the distance of, like model will predict this is a positive value. So so it is, what is the true class, what is the true class of xj? So yj would be -1, as it is a negative class, as you can see it is a negative class, the real it is a negative class, right? So y1 yj will be negative. But what our model will see, our model will see, okay, this particular data point is in the same direction of the w. So in that case actually the this particular distance, or this particular data point will be considered as negative value. So this is how the model actually predicts. So this is, so sorry, the model will predict this is a positive value, right? So as it is the same direction of the w. So if you take the parameters and try to multiply, so y1 wtx1, so this value is what, this value is negative, this is the true value, and this value is predicted by our model. So predicted prediction will be positive. So positive and negative would be, so positive multiplication with negative would be negative, right? So this, again this particular parameter gives me negative. So when this particular parameter actually coming a negative, and here also it is negative, so we can say our model actually misclassifying our data points. Okay, so this is all about the plane hyperplanes description. But what is the summary of this particular cases and the discussion, and how a model actually really works on that? So as you can see, so whenever this particular value is becoming positive, our classification is doing pretty well. Our algorithm actually classifies our data points pretty well. So whenever these particular values becomes negative, our model is performing wrong. So it is actually misclassified our data point. So what is the summary here? To find this particular W, W is nothing but what? The normal to the plane. So find this particular plane denoted as pi. So pi consists of what? I have shown you in the first video that pi consists of what? This W and bias. So bias is becoming zero as it is crossing to the origin. So this is the only variable available here. So if we can if you can change the w, means we can changing the parameter, right? So different plane value has different this normal or this w value. So it is a variable according to the different planes. So if you can consider this particular parameter yi wtx xy, so this particular value, so if this particular value becomes positive, actually at that particular scenarios our model is performing well. So we need to see, so which, like whatever this value be, it should be maximum, it should be positive, right? So larger positive value would be maximum values. So we can see, uh, we can take this particular value and write a function, write a function using various, like all the data points, whichever the data points is giving me best positive value. So we can select this particular, what to say, this particular, this value. So this value is means this is fixed value, right? It is already available in our training data, and this particular data point is also available in our training data. But thing is that only w is changing, right? So it is only variable here. So w transpose is the only variable. So if you can change the plane, so this wt will be changed. So we need to find this wt, right? So change the wt and find whichever give the max, this one. So we have to change this parameter to find the entire function which is giving me maximum, which is giving maximum of this particular value. So in the next video we'll see, okay, this all we understand to check, to take the maximum of this particular value parameter. Then what is the need of sigmoid value? So it we'll understand in the next video. So let's see why actually we need sigmoid value if you have already these particular parameters. So thank you guys, thanks for listening.